Almost 3/4 of the world's surface is covered by water. Where water is scarce, life is scarce. Wherever we find a lot of water, we find abundant life. Water supports life and is essential to all living things. If we could look closely enough into the water we use every day, we would find something like this. Scientists have discovered that all things, including water, are made up of tiny particles, and that the particles are constantly moving. These particles are called molecules. Let's imagine that these dots represent the tiny particles, or molecules, of water. The water molecules don't really look like this. In fact, the tiny particles of which water is made are so small that no one has ever seen them, so no one knows what they really look like. Here is a beaker of water. If we pour some sugar in and stir it, eventually the sugar will disappear. Where does the sugar go? We say that it dissolves, but what does it really mean to say that something dissolves? Sugar, like all materials, is made up of molecules. Each grain of this sugar is made of millions of these tiny particles. When the sugar is dropped into the water, tiny invisible molecules of sugar separate from each other and move around among the water molecules. The white dots stand for the sugar molecules. The moving water molecules and the moving sugar molecules often bump into each other and push each other around. The result is a mixture of sugar molecules and water molecules. The sugar is now dissolved in the water. What do you think will happen when we add equal amounts of sugar to equal amounts of cold and hot water? Watch. You can see the result. The sugar dissolves faster in the hot water. But why does it? Remember, we have said that molecules, the tiny particles of which materials are made, are constantly moving. Here's something else. When you apply heat to these moving molecules, they move even faster. When the sugar is added, it dissolves faster in the hot water than in the cold, because the sugar molecules get mixed much more quickly among the fast-moving molecules of hot water than they do among the slower-moving molecules of the cold water. We have discussed one important property of water, dissolving. Now let's look for some others. The towels and clothes on the line are full of water, but a few hours later, they're dry. Where did the water go? It's out there in the air, invisible. What do you think is rising into the air from the tea kettle? Yes, it's water. The boiling water is escaping into the air, just as water from these clothes escaped into the surrounding air. When water acts in this way, we say that it evaporates, which means it turns into a vapor or gas. There are many interesting things to learn about evaporation. For instance, how fast will water evaporate from the wet circle and square on this chalkboard? Not very fast if we just wait. But when a fan is turned on, the water evaporates faster. The moving air from the fan is making the circle evaporate quickly, but the square, which is protected from the air blown by the fan, remains wet. Why does a fan make water evaporate quickly? We have said that water is made up of tiny molecules of water, and that these molecules are always moving. Scientists have discovered that these molecules move so fast that some of them actually jump out from the surface of the water and escape into the air. That's how water evaporates. Some of the molecules return to the water, but when the fan is turned on, the moving air blows the molecules away, and they can't return to the water. In this way, the moving air from the fan speeds up the evaporation of the water. What do you think will happen if we turn on an electric heater and aim it at the wet square? The heat seems to make the water evaporate very quickly. Why does heat speed up the evaporation of water? We have said earlier that heat makes molecules move faster. When heat is applied to the wet square, the water molecules move much faster and escape more quickly into the surrounding air. Now, can you tell why wet clothes are hung out to dry in the wind and sun? Sun and wind make water evaporate everywhere. Where does all that water go? It goes up into the air, so there must be invisible water molecules in the air all around us. Look closely at that glass of root beer. What is the liquid on the outside of the glass? Is it root beer? The liquid tastes like water. But where did the water come from? Did it come from the air around the glass? Let's try to explain. First, we'll measure the temperature of the air and of the root beer. The root beer is 40 degrees, which is much colder than the air, which is 88 degrees. What do you think happens in the air around the cold glass of root beer? These dots represent invisible molecules of water that are moving in the warm air. These molecules got into the air from water that has evaporated. Watch what happens to the water molecules near the cold glass. As the water molecules in the air come near the cold glass, they get cooler and slow down. Many of them hit the glass and collect to form droplets of water there. Let's add some names. The water molecules in the air are called water vapor. When they collect into drops, they condense. The change from water vapor to visible water is called condensation. By speeding up the action with the camera, we can actually see water condensing on this cold glass. Have you ever seen water condense anywhere else? How about fog? Fog is simply invisible water vapor that has condensed near the cool earth to form tiny droplets in the air. In time, as the sun warms the air, all the fog disappears. The heat of the sun makes the tiny water droplets turn back into an invisible vapor or gas again. We say they evaporate. So far, we've talked about water as a liquid and water as a vapor or gas. There's a third state in which we can find water. Watch. By speeding up the action with the camera, we can watch the water changing from a liquid to a solid as it gets colder and colder. Most materials take up less and less space as they get colder. But water? Well, watch what happens to this bottle filled with water. We're closing the top of the bottle so that no water can get out that way. We're going to use a deep freeze to cool the water in the bottle below freezing temperature. We're doing this with care because it can be dangerous. You should not try to do it yourself. We are speeding up the action with our camera. The water freezes, and now, because frozen water takes up more space than liquid water, the bottle has to break. We say that water expands when it freezes. That means that it takes up more space. Now, let's find out what happens to water when it is heated. This flask is filled with water up to this mark. When we light the burner, the water begins to heat and rises in the flask. In other words, the water expands. The small amount of water in this flask has been heating for some time. A balloon stretched over the neck of the flask expands. This small amount of hot water is giving off enough water vapor to blow up this big balloon. Evidently, water expands greatly when it changes to a vapor or gas. The force of expanding water vapor, we call it steam, can be used to do many useful things. Not many years ago, most of our railroad trains were run by steam. Can you think of any ways that steam power is used today?